Hello, you're welcome. All right, so now here we are looking at vectors and scalars. All right, so now I'm going to start with a scalar quantity. So, what are scalar quantity in physics? Okay, now scalar quantities are quantities that can only be expressed in magnitude. Okay, so they are quantities that can only be expressed in magnitude. They have only magnitude. And what this magnitude means is size. So you can only express a vector quantity by its size and nothing more. All right. For example, this are please pardon me. You can only express a scalar quantity by its size. Okay. For example, time. Okay. So you can express the amount of time in hours, seconds, or even in minutes. All right, by the size, but not there is no such thing as direction of time. All right, time, distance is a vector, is a scalar quantity. Distance is a scalar quantity. Okay, speed is a scalar quantity. Speed is a scalar quantity. Work, the amount of work that is done can only be expressed in magnitude. It's a scalar quantity. Okay, and of course, what again? Temperature too is a scalar quantity. All the fundamental quantities are scalar quantities. All right, etc. While vectors, okay, a vector quantity, on the other hand, is a quantity that can, okay, not only be expressed in magnitude, okay, it doesn't just have magnitude, but can also be expressed in its direction. So it's a quantity that have both magnitude and direction. So for a vector quantity to be complete, okay, for you to represent a vector quantity completely, okay, you must represent both the magnitude of the vector and of course the direction to which the vector is acting. Now, a typical example is force. Okay, now if you say that a force of 20 Newton is acting on a body, the information is not correct, it's not complete. Why? Because the impact of this force depends on the direction. All right, let's say this body is experiencing a force of 20 Newton. Where is the force acting? Is it actually pushing the body forward, or is it acting on the body to push it backward, or is it acting downward? So direction, okay, matters in a vector quantity. Why? Because the direction of a vector quantity definitely will influence its magnitude, right? So a vector quantity is always represented in magnitude and of course in the direction. Then of course another example, we have acceleration. Acceleration is a vector quantity. Velocity is a vector quantity. Okay, moment of a force is a vector quantity. Momentum, they are vector quantity. All these quantities, okay, you don't just express them in magnitude by their size. Okay, magnitude is their size. You also express the direction to which they actually act. So our major focus on this video tutorial is on vectors. Okay, so let's get to it. So the very first thing I want to look at is the representation of vectors. All right, so for you to represent a vector, you should take note of the fact that a vector have both magnitude and direction, so you must represent the two. So representation of vectors. Okay, so There's if I want to represent a vector, I'll use a line, okay? Then with an arrow. For example, let's say I got a weight, and this weight, okay, a force is acting on this weight, okay? A force is acting on the weight, and that force is a force of 20 Newton, and is acting in the direction of 30 degrees north of east. Simple. All I just need to do is I draw my vertical axis. Vertical and horizontal, they are reference axis, okay? So that doesn't, this vertical axis for load, for any force that's acting vertically. This, the horizontal axis, any force that's actually acting horizontally, which includes okay, in the negative direction, of course, positive direction of the horizontal, but this force happens to at 30 degrees, okay, northeast. So I have the force. Now if I want to represent that force, I use this line, and I will definitely have to use an arrow. This arrow points in the direction of the force. That's a force of 20, a force of 20 Newton. And of course the direction, I still need to okay, represent the direction 30 degrees. All right, so this is how I actually represent vectors. Now you anytime you want to express vector, you don't just express the magnitude of the vector, you should also express the direction to which the vector is acting, okay? So the next thing I'm going to be looking at is the resultant of vectors. Resultant of vectors. Now, of course, if we are talking of a resultant of vectors, that means we are dealing with not just one vector, we are dealing with many vectors, okay? So what is the resultant of vectors? The resultant of vectors is simply the result, okay, of adding vectors. The result you get when you add vectors, that is known as their resultant. Of course, since vectors have direction, okay, their resulting effect can be added. So resultant is the result of adding vectors. That's the resultant of vectors. Okay. Now, depending on the direction of the vectors, there are different methods to which we add vectors. We are going to look at case scenario. Okay. So in this case, we are just going to start with just the resultant of two vectors. Okay. Resultant of two vectors. We are looking at how to find the resultant of two vectors. Now, the resultant of vectors can also be called the equilibrant of the vectors. Okay, because anytime you resolve a resultant of vectors, you have a single vector whose value and whose magnitude and direction is equal to the other two vectors. So that particular single vector that you call the resultant is also known as the equilibrant. Okay, of course, you will learn more about equilibrant when we do the equilibrium of forces. All right, so now since we are dealing with the resultant of two vectors, now the way we add two vectors depend on their direction, okay? So we are going to look at some different cases, okay, based on the direction of the two vectors. Let's look at the two vectors acting in the same direction. Same direction. The two vectors, okay, are acting in the same direction. Now, a typical example is when I have a load and this load is being pulled by two forces. Let's say force F1 and force F2 in the same direction, and I'm being asked to find the resultant of these two forces in the same direction, and that's going to be, the resultant is going to be equal to the sum of the two forces. So when vectors act in the same direction, you want to find the resultant, you just add it, right? And of course, since the resultant is also a vector quantity, I should also express the resultant. So the resultant of these two forces will also go in the same direction with the two forces. So which simply means that if I'm asked which direction would this load move, okay, if these two forces act on it, of course it's going to be in this direction, the direction of the east. Okay, it will go eastward. All right, so let's look at where you have F1 to be 20 Newton and F2 is 10 Newton. So you'll be asked to find the resultant. Simple. The resultant, okay, is just gonna be 20 plus 10, and that's 30 Newton in the same direction. All right, so let's proceed. Let's look at a case where the two vectors act in opposite direction. Opposite direction. So it's like having a load. To illustrate this, it's like when you have a load and two opposite forces drags on the load. One drags it rightward. Let me call that F1. The other drags the load leftward. Okay, so let me call this F2. The one that. So if you are being asked to find the resultant of the vectors, definitely you have to subtract. That's going to be F1 minus F2. Why? Because the two forces are actually opposite. One is acting in the positive direction, one is in negative direction. Okay, of course, if you are actually considering it being horizontal axis, of course you know that this direction is positive and this direction is negative. So any force that is actually acting in this direction goes with minus. Okay, so that is why we subtract. That's gonna be F1 minus F2. Now the question is, which direction do you think the resultant will go? The resultant will go in the direction of the larger force. That means if I have two person, okay, two individual dragging on this load, okay, so this load will have to go in the direction of the one that is that have the larger force, and in this case is F1. Okay, the line of F1 is larger than the line of F2, so please take note of that. All right, as we proceed, now we look at number 3 scenario. This time around, these two vectors F1 and F2 are perpendicular to each other. Okay, so they're acting perpendicular. So if they are perpendicular, if two lines are perpendicular to each other, it simply means that the angle between those two lines, okay, is 90 degrees. The angle between the two lines is 90 degrees. So I'm having F1, that's going to be F1 acting vertically and F2 acting horizontally. So the question is, which direction do you think the resultant will be? Since both F1 and F2 is not horizontal as compared to what we have here. Okay, F1 and F2 they're all horizontal, but here I'm having F1 being vertical, F2 being horizontal. That simply means that the resultant is going to be a line, okay, that cuts the vertical and the horizontal line. Okay, so that becomes my resultant. So this line becomes my resultant. But the question is, how do I get this resultant? Okay, well, that's going to be the direction of my resultant. Okay, so that means my resultant will be a line that is inclined, okay, at an angle between F1 and F2, and that the direction of that resultant, okay, is going to be will be an angle theta. Okay, so the resultant is going to make an angle theta with F2 with the horizontal. Now, but my interest is how do I actually get the magnitude of my resultant, the R, when the two vectors are inclined at, when the two vectors are perpendicular to each other. This is why you apply Pythagoras rule, okay? So for you to actually get the resultant, you use Pythagoras rule. And what's Pythagoras rule? The resultant is going to be equal to the square root of f1 square, then plus f2 square. F1 square plus f2 square. All right. Now, what is the direction? Remember, the direction of the resultant is inclined at an angle theta. So how do I get that direction? I'm just going to use ratio to get that direction. So the direction theta, I will find it by just finding the tan inverse of f1 all over f2. That's how I'll get the direction. Okay, let's look at a typical example. Let's see a situation where a question read this way. Okay, a car move 20 kilometer due east. So I draw it, that is 20 kilometer due east. And then move another 20 kilometer due north. Okay, so I'll draw the line, another 20 kilometer due north. So the question is evaluate the displacement. So displacement is something as the resultant of these two. Displacement between these two distance is the resultant, okay? So that's what it simply means. So how do I get the resultant? Simple. The resultant is going to be equal to the square root of f1 square, which is 20 square, plus f2 square, which is also 20 square. All right, so let's do that. So that's going to be equal to 400. 20 square is 400. 400 plus 400. So which of course is the square root of 800. So if you evaluate 800, you can do it in a short form, okay? The square root of 800 is something as the square root of 400. 800 is 400 times 2, right? 400 is a perfect square. Then times 2. So I can find the square root of 400. Okay, it's a perfect square. The square root of 400 is 20. Then I can leave the square root of 2 in a short form. Or you can use calculator to do it to get your answer in a decimal point. All right, that's by the way. Okay, so this is the resultant in magnitude. But remember, the resultant also should also have direction. Why? Because the resultant is a line that, okay, cut in between these two. So the resultant is gonna have the direction theta. All right. So how do I get that theta? That theta, that direction theta, this angle here is gonna be tan inverse. Tan inverse of 20 f1 all over f2, which is also 20. So that means theta is going to be tan inverse of 1. 20 all over 20 is 1, okay? So when you use your calculator to do tan inverse of 1, what you will have is 45 degrees. Okay? So theta will be acting 45 degrees, okay? And that's going to be north of east. All right. So we proceed. I will possibly get to solve some more question, okay? I have to solve some more question, all right? Then before then, I want to give you the opportunity to go through all go through all that I've actually treated in this particular video, okay? Especially the resultant. Get to know how to evaluate resultant of vectors when they're acting in the same direction, opposite in direction, and of course perpendicular. I want you to learn that one more time, then after which we will continue. All right, see you in the next video. Thank you very much.